So we are going to start with a new topic, that is analytic equations or analytical equations. We are provided with some function f of z, and if this f of z is very well defined in the domain, then it will be said that f of z is an analytic equation or analytical equation if it satisfies two major points, that is if f of z is continuous and if f of z is differentiable at every point of the domain. So I would like to add one more statement related to this analytical equations because this might appear in your GATE examination. So the statement is every analytical function is differentiable but its converse is not true. I am just once again repeating the statement. Every analytical function is differentiable but its converse is not true. So just note down this statement. Consider we are provided with a function f of z as f of z equal to u of xy plus I v of xy, where this u is considered to be the real part of complex function and v is considered to be the imaginary part of the complex function. This function will be considered to be analytical function if it satisfies Cauchy-Riemann equation. If it satisfies Cauchy-Riemann equation. So what is this Cauchy-Riemann equation? So Cauchy-Riemann equation is something w by w x equal to w v by w y, and second one is w v by w x equal to minus w by w y. If the given function, that is f of z, if it satisfies both of this equation, then we say that the given equation or the given function is an analytical equation or it is an analytical function. So let us consider one example to check whether the given example or the given function is analytical or not. So let's consider f of xy equal to z cube. So we know that z is given as x plus iy. So z cube will be something equal to x plus iy the whole cube. If I expand this x plus iy the whole cube, then I found that it will be equal to x cube minus 3xy square plus I 3x square y minus y cube. So this will be my real part, or I am representing it as with a letter u, and this will be my imaginary part which I am representing with as v. So let's check whether it satisfies the Cauchy-Riemann equation or not. So the Cauchy-Riemann equation, so w by w x, which is equal to 3x square minus 3y square. Similarly, w v by w y will be equal to 3x square minus 3y square. So we can, over here we can say w by w x is exactly equal to w v by w y. Let's check the second condition, that is w v by w x. So w v by w x is equal to 6x y, and similarly w by w y will be equal to minus 6xy. So over here it is satisfying the second equation also, because over here we can see that w v by w x is equal to minus of w by w y. So it is satisfying both of this Cauchy-Riemann equation. So we can say that the given function, that is f of xy equal to z cube, is an analytical function or it is an analytic equation. So let us consider one more example, that is f of z equal to sine of z. So we know that z is a complex number, so z can be written as x plus iy. So we can rewrite this equation as sine of x plus iy. So we know that this sine of a plus b can be written as sine A cos B plus cos A sine B. So we will write this equation as sine of A, that is sine x, into cos B, that is cos Iy, plus cos A sine B, so cos x into sine B, that is sine Iy. But if we observe this equation, we cannot observe that this real and imaginary part as a separate one, but we are observing that real and imaginary part are put together. So we need to separate this equation into imaginary and real part. So we can rewrite that cos of Iy as equal to cos of hyperbolic y, while we can rewrite this sine of Iy as I sine hyperbolic y. So this equation can be written as sine of x cos hyperbolic y plus cos of x, I will write I over here for my convenience, into sine of hyperbolic y. So now I can say that this as my real part and this as my imaginary part. So let's check whether it satisfies the Cauchy-Riemann equation, that is given by w by x, so which is equal to cos x cos hyperbolic y, and w by y is equal to cos of x cos hyperbolic y. So we can say this w by x is equal to w by y. So it is satisfying the first equation. Let's check the second equation. It is given by w by x, which is equal to, so w by x is equal to minus sine of x sine hyperbolic y, and w by y is equal to sine x sine hyperbolic y. So we can say that w by x is equal to minus of w by y. So we can say that it is satisfying Cauchy's first and Cauchy-Riemann first and second equation. So from that we can say that given equation, that is f of z equal to sine of z, is analytic. Okay. So that's in this way we can check whether the given equation is analytic or not. So there are some tricks associated with this analytical function, or I can say there are some tricks to identify how to check whether the given function is analytical or not. So let's check one by one. If the function contains z bar, then it is not analytical function. Z bar in the sense the complex conjugate. If we are considering function z as x plus iy, then z bar can be written as x minus iy, or I can say if the complex function is represented in such term or z bar term, that is x minus iy, or I can say 3x minus 3iy. If it is expressed in something like this, then we can say the function is not an analytical function. So I am considering one example. If we are provided with the function 3 plus x minus iy to the power 7, then we can rewrite this equation as 3 plus z to the power 7, z bar, because over here it is x minus iy. So this given function consists of a z bar, so the given function is not analytic. Let us consider a second trick. If the function cannot be expressed in terms of z, then it is not analytical. Expressed in terms of z, or I can say if it is unable to expressed in terms of x plus iy. Over here I have written 3x plus 3iy, so I can rewrite it as 3x plus iy. So in this way I can represent in terms of z. So if we are provided with a function that is 7 minus 7x plus iy to the power 7. So over here all the way it is a complex, so I am considering minus over here. If I am considering the equation, 7 minus 7x minus iy to the power 7. So over here it is 7 minus, so there is some extra term called as a 7 over here, due to which I am unable to express in terms of z. The reason why this function is not analytical, because we cannot express this equation in terms of z, because if there was a presence of 7 over here, then I was able to express it as 7 minus 7z to the power 7. So z is important. If there is absence of this term z in the given function, then we can say that the given function is not analytical function or analytical equation. So let's go to the third trick, that is a function contains the power, or if it contains the fractional power of z, then it is not an analytical function. If we are provided with a function z to the power 1 by 2, then we can say that this function is not analytical function. Or sometimes we are provided with a function something like this, x plus iy to the power 1 by 4. So we can rewrite it as z to the power 1 by 4. So over here the power is in terms of fraction, then we can say the given function is not analytical. So these are some tricks related to analytical equation, or I can say how to identify whether the given equation is analytical or not. I am providing with some equations over here. Just try to solve those equations. Something x plus iy to the power 7 into 1 minus x minus iy to the power 3. Check whether this equation is analytical or not. Second one, x square minus y square plus 2ixy minus 3 to the power 3. Then 1 minus x plus iy to the power 7, 2 plus x plus iy to the power 3. Check whether this all three equations are all analytical or not. So this is your homework. Hopefully you have understood this lecture. So we will meet in the next lecture, in which we are trying to solve some applications related to this analytical equations. So thank you.